Now we're going to take a look at some of the operations in the graphical way to represent the composition and algebra functions. It says a pebble is dropped into a calm pond, causing ripples to form concentric circles. Those are the little circles that get bigger and bigger and bigger as the pond weight moves out. The radius in feet of the outer ripple is r of t equals 0.6 t, where t is the time in seconds after the pebble hits the water. The area of the circle is given obviously by the area of r equals pi r squared. It shouldn't be too surprising. Find the area of r of t. So what it's asking is the area of r of t. That's going to be the area of 0.6 t. What's that saying is that this function right here is saying that given the fact that the radius is dependent upon the time, well, that means that the area is dependent upon the time. So at any given moment t, the area of the function will equal pi times r a sub t equals, excuse me, give me a second, let me delete this here. The area will equal pi times, in this case, our input is 0.6 t squared, which equals 0.36 pi times t squared. Now the domain. We don't have any radicals, so we don't really have to worry about any imaginary numbers creeping up. We don't have to divide, but we're not dividing anything, so we got to worry about zeros in the denominator. But there is an implied domain. Because we're dealing with time, we know that t just has to be greater than 0. You have to obviously, there has to be time to have passed from when you dropped the rock into the water for it to actually have an area. It could equal 0 as well. Based on the graph below, find f plus g of 3. For me, I like going back to the basic definition of f of negative 3 plus g of negative 3 in order to find the solution. If f of x is our purple graph, we go to negative 3, 1, 2, 3, to find its f of negative 3 is, 1, 2, 3, negative 3 as well. So this will equal negative 3 plus g of negative 3, which equals 2. So if we were to add the two, we'd come together to get negative 1. F of g of 2 is going to take this input of 2. We're going to say, what is our g of 2 value? When we go to g of 2, 1, 2, it equals 1. So g of 2 is the same thing as 1, which means we're looking for f of 1. In this case, f of 1 is all the way down here at negative 3. F minus g of 5, or g minus f of 5 is g of 5 minus f of 5. G of 5, again, our red function, will be 1, 2, 3, 4, 5. It looks like we're up 3. Minus f of 5 looks to be about negative 1. 3 minus negative 1 becomes 3 plus 1, which is 4.